in Lesson 6-2, we're going to get more into that exponential function, not just the properties of exponents. So it's important to recall that a domain is the set of x values a function can have. A range is the set of y values a function can have. You'll probably be asked the question of what is the domain and range in math a lot for the rest of your math career. So when it comes to a function like 2 to the x power, this is what an exponential function looks like. So if we look ahead here, we're going to have some number, some b constant, called a ratio in a minute, to a letter or an exponent power. Now there can also be another number out front, and we'll get to more of that in a second. But for example, if we were going to graph this, if we plug in 0, try on a calculator, 2 to the 0 is 1. 2 to the 1 is 2. 2 to the second power is 4. If I fill in some of these, and I remember 2 to the negative 1 is 1/2, 2 to the negative 2 is 1/4. That's why it's important to remember those exponent rules. The y-intercept here is 0, 1, so we could go plot that here on our graph. And we could plot these other points. At negative 1, we're at 1/2. Negative 2, we're at 1/4. 1, we're at 2. 2, we're at 4. 3, we're at 8. So if we connect these, we have an interesting graph. We're used to graphs that are lines. We've seen an absolute value graph recently. These are kind of interesting. They're kind of bendy, but they're definitely not balanced. As x goes to infinity, so as I put in bigger and bigger x values down here, all this graph is going to do is go up to infinity as well. Now, also we could note though, as x goes to, I'm going to change the color here so we can change it. If x is going to negative infinity, as we come over here, the y value is going to 0. It really just seems to be leveling out here. It will never actually have a y value of 0. So it doesn't have an x-intercept. That's what this will say here. Even if you look on Desmos, it looks like it's going to hit 0. It never does. We call that line an asymptote. That means it will never touch this line here at y equals 0. An asymptote, by definition, is the line of a function that it will never cross. So if we're talking about, remember this little look of this graph here will be your general look for all exponential functions. The domain of it is all the x values, remember? So I can put in any x value I want. So that would be all real numbers. However, my y values, when I look for the y values that this function can have, it seems to be going up forever. That's my y value to infinity, but it will level out here at 0. So we would say our y values have to be greater than 0 in this case. Now remember the functions we've learned about. Lines, or absolute value functions, or even parabolas if you've heard of these before. They're called quadratic functions. They look different. All of these have a different look. Lines have nice steady increases, and so do absolute values, just in both directions. Quadratic is a little more bendy, and so are our exponential graphs. So something to keep in mind, your exponential graphs will look like this curve. Sometimes they go the other way. We'll talk about that later. But our function, the equation of an exponential graph, will always be a number to a power of x, and sometimes it'll be times another number. We're going to remember this first number here is always an initial amount if we're applying it to a real-world application, and b will be our constant ratio. So if I look at this example here, my initial amount here at 0 is 4. This table starts with a 0 amount of 4. The ratio, let's look what happens every time we change these y values or the outputs. It's multiplying by 3. So that will be our ratio, the rate we multiply. If we want to come up with a function for this table of values, notice how it's not like a line anymore. It's not adding an amount. We would say our initial amount is 4 times our rate that we're multiplying each term by of 3 to the x. Now, if you ever look at a graph, your initial amount here is that y-intercept. We could start at 128, and as we look down here, our y values, this is actually being divided by 2. So a rate is usually a multiplying. Well, dividing by 2 is the same as multiplying by a half. So our function for this exponential equation is 128 times 1/2 to the x. If you were ever given an equation like these purple ones here, it'd be important to remember that order of operation says you don't want to take 4 times 3 first. You'd have to take 3 to the power, let's say of 1. 3 to the first power is 3, and then times 4. So when I plug in a 1, right over here, 3 to the 1 is 3, times 4 is 12. Now you can make exponential equations out of points also. You could plot them on a graph, but look at, there's our y-intercept. My initial value, my starting value is 3. That's my initial value. Let's check what's happening to these y values as we go up. Well, 3 times 4 is 12. 12 times 4 is 48. All of these are a rate of multiplying by 4. So my b value is going to be 4 because that's my rate or ratio. So my exponential function would be my initial value times the rate the values, y values are multiplied by, to the x.